The lesson today is on the unit circle and the Pythagorean trigonometric identity. By the end of the lesson, you should be able to recall how to measure angle in a Cartesian plane and recall the quadrants of the plane. You should be able to establish the Pythagorean trigonometric identity using the equation of a unit circle. Now you should remember the significance of sine, cosine and tangent on the unit circle and cast. I'll explain cast a little bit later. Use the unit circle to estimate the value of the sine, cosine and tangent ratios at any given angle. You should be able to establish and use the parity, complementary and supplementary identities with the unit circle. And finally, you need to be able to review the exact values in degrees. Now, let's have a look at measuring angles. It is always measured from the positive x-axis, which is this line here, the positive x-axis. Alright, anti-clockwise, which is that way. It's always positive. Alright, it could be, another term for it is counterclockwise. If we go clockwise from the positive x-axis, the angle is negative. Alright, based on this, let's pause the video for a while, look at your worksheet and try to measure these angles. Draw it on the Cartesian plane. Alright, number 1, you know that 120 degrees, if I measure positive angle 120, I start from the x, positive x-axis, and that is about the right position for that. So it's 120 degrees minus 45 degrees. You want to measure minus 45 in the clockwise direction, and that is about 45 degrees. Minus 130, so you know from here to here is 90 degrees, and to here that's about 130 degrees. Minus 130 degrees. Make sure that you show the angle, minus 45 degrees. Now 270 degrees, which is 3 times 90 degrees. So it's up to here, 270 degrees. And minus 90 degrees, that way. This is minus 90 degrees. Now, note that you need to realize that 270 degrees is actually the same as minus 90 degrees. Is how it is measured, where it is measured from, that's important. When you come to number 6, which is 750 degrees, which means you have done several rotations. First rotation is 360. Second rotation is 720. And then you add another 30 degrees somewhere around here. Alright, so that would be your angle, 750 degrees. Alright, so realize that when you measure angle, clockwise is negative, counterclockwise or anti-clockwise is positive. Now, let's have a look at a unit circle. You should recall that for a unit circle, the radius is always 1 unit, and the center is always from the origin, 0, 0. So we know, using Pythagoras' theorem, the equation of the circle is x squared plus y squared equals 1. Now, let's have a look at the circle again from the triangle. So if I take the triangle out, you know that it is right angle triangle. Can you actually tell me what sine theta is? You should know that sine theta is y over 1, which is the hypotenuse, which is therefore y. Cos theta is x over 1, therefore cos theta is x. Now, can you now link this to coordinate of this point over here, x and y? Alright, so let's have a look at the unit circle. For the unit circle, x is actually cos theta. and y is actually sine theta. Alright? So since the equation of the unit circle is x squared plus y squared equals to 1, therefore cos square theta plus sine square theta is actually 1. This is actually the Pythagorean trigonometric identity. Alright? So remember, in a unit circle, x coordinate is the cos of the angle, and y is actually the sine of the angle. Now, let's have a look at some identity. First is the complementary identity. By definition, cosine actually stands for co dot sine, which stands for the complement of sines. We know that complementary angles sums up to 90 degrees. So, consider the value of sine 30 degree and cos 30 degree. Therefore, we can actually say that sine theta equals to cos 90 minus theta, and cos theta equals to sine 90 minus theta. Remember, if I draw a triangle, right angle triangle, with 60 degrees here, and this 30 degrees here, and we know that this is 2, 1, and square root of 3 units, you know that sine theta, sine 30 degrees, is actually half, and cos 30 degrees, 60 degrees is actually half. So therefore, you can say that sine 30 degrees equals to cos 60 degrees, which is the complementary identity. Now, let's consider tangent theta. We know that looking at the triangle, tangent theta is y over x. And since y is sine theta, x is cos theta, therefore tangent theta is sine theta over cos theta. Now, we need to think about the interpretation. Number 1, tan theta is the vertical over the horizontal. And this is actually the ratio of sine to cos. X is cos theta, y is sine theta. Right? The next one. Think about tan theta. The gradient of the line segment from the center of the circle to the circumference, which is the gradient of the radius at the angle theta. Right? And finally, last but not the least, tangent theta is the gradient of the line segment that is perpendicular to the actual tangent, which is that here. Alright, that is the tangent. So now, let's think about the 4 quadrant. You know that in the Cartesian plane, we have 4 quadrants. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. First, second, third, and fourth. Now, let's start thinking about measuring angles. If I start off with 0 degrees, going to clockwise direction, 90 degrees, 180, 270, and 360, 450, 540, 630, and so on and so forth. Now, if I measure this way, alright, I will go from 0 to minus 90 degrees, minus 180 degrees, minus 270 degrees, minus 360 degrees, and so on and so forth. Alright, so think about the direction, whether it's positive, whether it's counterclockwise or clockwise. So counterclockwise, anti-clockwise, positive. Alright, now, we know that looking at the quadrants, all the coordinates in first quadrant is positive. X is positive, Y is positive. Different for second, third, or fourth quadrant. So let's consider the trigonometric ratio. So for any angle in the unit circle, cos theta is x, sine theta is y, tangent theta is y over x. So therefore, let's think about first quadrant. First quadrant, because x and y is positive, so therefore cos theta, sine theta, tan theta all are positive. Second quadrant, x is negative, y is positive. So, what of the which trigonometric ratio is positive? It's actually sine, because sine theta is y. Y is positive. Cos theta is negative. Tangent theta, which is y over x, positive over negative, therefore is negative. Third quadrant, cos and sine, they are both negative. However, tangent will be negative over negative, therefore is positive. And then fourth quadrant, cos is positive because x is positive. So that leads me to what I call cast. Cos, all, tangent, sine, and tangent, cast. So there are a lot of ways of remembering it, but once you know that first quadrant is all, and you apply CAST, you do know that fourth quadrant is cos, positive. First quadrant is all positive. Second quadrant is sine positive, and third quadrant is tangent positive. Cast. It's a good way of remembering it. Now, we are going to review the exact value of all the angles, 30, 45, 60. This is the unit circle, and you should have a copy of this. I will discuss this a little bit more tomorrow when I talk about radians. But at this stage, you need to know that 30 degrees, you will be able to read the sine and cos directly from the unit circle. So these are given all in exact values. You can also see that when we plot the graph, for example, this green line is actually the tangent of theta, and it goes all the way up until it's 90, which is undefined. 90, which is undefined, and 270, which is undefined. Whereas the red line here is cos, and the blue line here is sine. All right. Now, let's review. Can we think about the exact value of 0 and multiple of 90s? So I've got 0 degrees here, 90 degrees here, 180 degrees here, and 270 degrees here. All right. So we know this is a unit circle, and therefore the coordinate here is 1, 0. Coordinate here is 0, 1. The coordinate here is -1, 0, and therefore here would be 0, -1. All right. So let's think about how we will work out the exact value. So for 0 degrees, what would sine theta be? Sine theta is actually 0 because y is 0. Cos theta will be 1 and tan theta will be 0. All right. Whereas for 90 degrees, sine theta is 1, cos theta is 0, and because 90 degrees, when you're looking at tangent theta, which is y over x, 1 over 0, is actually not defined, which is the gradient of said line. So therefore, you can think about this is 0, 180 degrees, 360 degrees, and so on and so forth. Whereas this would be 90, 270, and so on and so forth. Vertical line and horizontal line. The next thing you need to know is the supplementary identity. Now, consider the following values: sine 80 and sine 0 degrees. Hence, for any angle, we could establish the identity sine theta equals to sine 180 degrees minus theta. So let's just take, for example, this is 30 degrees. Sine 180 degrees minus theta would be that. Correct? Because that is 30 degrees. So therefore, you can see that if I draw a straight line, the y value is the same. Therefore, we could say that sine theta equals to sine 180 degrees minus theta. Y equals y. The next one, let's think about the supplementary identity. Again, let's consider cos theta and cos 0 degree and cos 180 degrees. Alright, right opposite. So cos 180 degrees, for cos 0 degrees is 1, x is 1, 180 degrees, x is minus 1. So therefore, we can say that cos theta equals to minus cos 180 degrees minus theta. Or you could actually think about, again, using 30 degrees. Alright? If you're using 30 degrees, you can see that this is 30 degrees. This is 180 degrees minus 30 degrees. So if there's a value of x here, this is negative x. So therefore, cos theta is minus cos 180 degrees minus theta. Now, what about the parity identity? Alright, let's think about sine 90 degrees and sine minus 90 degrees. So 90 degrees is here, and we have got x is 0, y is 1. X is 0, y is minus 1. So 90 degrees that way, 90 degrees this way, minus 90 degrees. So when for any given angle theta, we can therefore establish sine minus theta is the same as minus sine theta. Now let's talk about using the same thing, but we want to talk about cosine. Again, 90 degrees here, and minus 90 degrees here. 0 and 1, 0 and minus 1. Since we know that x is actually 0, so therefore cos 90 degrees is the same as cos minus 90 degrees, and therefore we can say that cos minus theta is the same as cos theta. So just a quick summary, you need to know the complementary identity, the supplementary identity, and the parity identity. Alright? Now, let's quickly, without your calculator, see if you can work out the value of A, B, C, D, and E. Alright, I will actually give you a few minutes to work on that. Alright, A, B, C, D, E, and F. Now, maybe I'll give you the first example. You know that 137 degrees is actually 180 degrees minus 43 degrees. Alright, therefore, sine 137 degrees is the same as sine 43 degrees, which is approximately 0.6820. Part B. Think about part B. What could you do? Alright, you know that sine 59 degrees is the same as sine 180 degrees minus 121 degrees. So therefore, it's approximately 0.8572. Cos 43 degrees, that should be the same as minus cos 180 degrees minus 37 degrees. Which means that would be 0.7986. Similarly, cos 24 degrees should be the same as minus cos 180 degrees minus 156 degrees, which is approximately minus 0.9135. Alright, sorry, it's plus 0.9135 because it's minus times minus. And sine 115 degrees is the same as sine 180 degrees minus 65 degrees. So therefore, it's 0.9063. And finally, cos 132 degrees should be the same as minus cos 180 degrees minus 48 degrees. So therefore, it's approximately 0.6691. Alright? It's actually, yep, that should be minus 0.6691. Think about it. Cos 132 degrees is there. Alright, and it's CAST. Alright, let's quickly review the exact values. Now, if you cannot remember how to derive this, for 30 and 60 degrees, draw an isosceles triangle, equilateral triangle. 60 degrees, 60 degrees, 60 degrees. And all three sides would be 2, 2, and 2. So if you split that into 2, you've got 30 degrees, 60 degrees, 2 units, 1 unit, and therefore this square root of 3. And you can derive your exact value of 30 and 60. What about 45 degrees? Let's say this is 1 unit, that should be 1 unit, therefore this is square root of 2. And again, you should be able to derive your sine, cos, and tan from this triangle. Now, can you now determine all this angle, sine 120 degrees? That should be sine 180 degrees minus 120 degrees, which is sine 60, which is root 3 over 2. Cos minus 120 degrees is minus cos 180 degrees minus 120 degrees, which is minus cos 60 degrees, which is minus half. Minus sine 45 degrees is minus sine 45 degrees, which is minus square root of 2 over 2. And finally, cos minus 135 degrees. Oops. Let me clear that. Is cos minus 135 degrees is the same as cos 135 degrees, which is minus cos 45 degrees, which is minus square root 2 over 2. Alright, this is actually the end of the lesson. I hope what I've taught you, you could really think about how to measure angle in Cartesian plane. You should be able to establish the Pythagorean trigonometric identity and review the significance of sine, cos, and tangent on the unit circle. Remember cast. You should be able to use the unit circle to estimate the value of the sine, cos, and tangent ratio at any given angle. You should be able to use the parity, complementary, and supplementary identities with the unit circle. And finally, you should understand how to use the exact values in degrees.